Since sequences are fundamental to computing, people have developed new kinds of statements that help us manipulate or iterate over sequences. And one of them is the for statement. So the for statement is a way of iterating over sequences. I'll show you an example, and then I'll tell you exactly how it works. I'll write a function that it computes the count of the number of times in a sequence S that some value appears. Count the number of times that value occurs in sequence S. And using a while statement, I might write something like total index equals 0, 0. While it's the case that index is less than the length of the sequence, I'm going to look at the element at index of S. So now I've selected one particular element of the index, and if I start out with index is 0, I'll pick the 0th element, and if I change index later, then I'll get another element later on. So at some point down the line, I will rebind index to index plus 1, and in this way, I'll march through all of the elements of the list. And what do I do with this element? Well, I want to figure out if element is equal to this value that I'm looking for, and if so, then I'll change total to be total plus 1. And at the end, I can return total. So what have I done so far? I've defined a function called count that takes in some sequence and counts the number of times that, say, 1 appears in that sequence. Oh, there it is, 3 times. 1, 2, 3. Okay, so that's a useful doc test. Let's just paste that in right there. And then we'll talk about this implementation. Well, let's try to make it shorter. One thing we see here is that total is rebound to total plus 1. There's actually shorthand in Python for doing that. I can just say total plus equals 1. And this is a different assignment operator that assigns total to be whatever total was before, and then 1 more. And I can do the same thing here and simplify that. Okay, so we've made some progress, but I think we can do better. The meat of this implementation is here. And the rest of this is just doing the work of iterating over all the elements in a sequence, which is such a common thing that we have a special statement for it called the for statement. And a for statement allows us to just forget about the index entirely. And instead of saying while index less than len S, I just say for every element in S. And that replaces both of these lines and allows me to get rid of the index increment at the bottom. So now if I read out what this implementation says, it says I'm going to keep track of the total number of times I've seen value in S, and for every element in S, if element is that value, then I'll increase the total by 1. If I run the doc tests, I'll see that it tried to count 1 in this sequence. It was expecting 3, and that's exactly what it got back. 1 test passed. Okay, so that was an example of sequence iteration, where we used a for statement. And how does it work? Well, what happens is that the name element is bound in the first frame of the current environment, not the new frame, by the way. No new frames are introduced with a for statement. But the name element is bound, and then the suite of the for statement is executed. And then the name element is bound to the next thing in S. And we execute this again. So, when you have a for statement, it's going to execute the suite of the statement a number of times, which is the number of elements in S. An element will be bound to a different element of S each time. So here's the execution procedure spelled out. The syntax of the statement looks like this. You need a name, you need an expression, and you need a suite. The first thing that happens is you evaluate the header expression, which must yield an iterable value. Now I said we're doing iteration, and iterable values are related to that. But this is a term that I won't define precisely for several weeks. But for now, just think, this expression needs to evaluate to a sequence. Later on, we'll see that there are other things that we can put in there besides sequences and iterate over those as well. But for now, just think, I need an expression that gives me a sequence. I need a name to give to each element in that sequence. And then for each element in the sequence, we'll bind that name to the element in the current frame and then execute the sweep. One more cool feature about for statements is that you can actually do sequence unpacking right inside the header of the for statement. So let's say I had a list of lists. I call it pairs here, and I want to count the number of pairs that are just the same element twice. So I'm going to go through each pair, and I'm going to say, is 1 the same as 2? No. Is 2 the same as 2? Yes, so same count will be 1 more than it was before. 3 and 2 are different, but 4 and 4 are the same. So we'll increment same count again. Now what does the for statement look like that can do that? This is something that only works for a sequence of fixed length sequences, such as a sequence of pairs. But in that case, then you can unpack each pair into separate names. So you can say for x comma y in pairs. Pairs is a sequence of pairs. X and y are actually now bound to the elements in each pair, as opposed to the pair itself, at which point you can check if x equals y, and if that's true, then change same count to be same count plus 1. So you're giving a name for each element in a fixed length sequence here, and that's called sequence unpacking. And this looks just like multiple assignment, when you'd say x comma y equals some pair. Each name here, x and y, is bound to some particular value in a pair.